Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us move to the next module under part 5 of our topic of bridge engineering. So in this module, we will talk about types of bridge structures. Let's listen. So there are several types of bridge structure. So let's start with this type. This is what we call deck arc. Deck meaning under the bridge, no? Okay, under. So the arch portion is under the bridge, okay? So, and supporting it, supporting the bridge. So the arch portion is supporting the bridge over it, on top of the arch. So meaning the arch portion is actually this one. So this is the arch portion. So arch. Okay. So previously I call it arc, but I found out that the spelling of arc is A-R-K. So when I search for this, it is a very difficult pronunciation, arch. So the root word for architect, so but architect, arc, not architect. That is wrong. Architect is wrong. So architect, but this is arch. Okay, so deck arch. Generally true, arch, entire arc located below the deck, generally used in depth valleys with the step walls. Okay, so may use half-through arch to keep bearings above high water elevations. This is the general description of a deck type of arc bridge. Okay, through arch. Okay, so the arch portion is on the what? Superstructure. Okay, not the on the substructure. So deck arc, if the arc portion is on the substructure, but this one is superstructure, generally tied arcs. So tied meaning there are cables, there are steel cables like this. So that is tie. So tied arcs, often used when under clearance is limited. So arcs below it is not possible because there might be somewhat sea vehicles or ships, boats that may travel below it. So clearance might be limited. Effective where deep foundation are required. Above deck portion of the half-through arch can be a tied arch. So, okay. So as you can see, okay. So it is a tied arc. Usually, if they use through arch, that is generally a tied arch. They are almost similar. So partially through arch, partial through arch can be either through or tied arch. Through arch or tied arch. Okay, partial through arch. Through meaning passing through. Okay, so going through. That is what we mean by the word through here, as the context of this name. No? So passing through or going through that bridge. Okay. So this is what we call the partial through arch type of bridge. Deck truss type of bridge. So deck truss type of bridge. So the what? Substructure. Actually, this is still a superstructure. Okay, because it is what? Directly supporting the what? Pavement. Okay. Okay, so this is still what? So the bearing is located here. The bearing is located here. So this is above the bearing. So it is actually the truss are still on the superstructure. Okay. Floor beams frame into top chord or rest of the top. What do you mean by top chord? So this elements 1, 2, 3, the single element, metallic element, steel element, from one joint to another is what we call top chord. From, for example, this one. But even if they are not cut off from one joint to another, even if this is continuous from this point to this, what? This is the what? The wing, okay? So even if that is continuous, it is also called what? Chord, top chord, okay? It's top chord. Truss spacing closer than for true truss, okay? So trusses meaning these small segments, the small elements of steel components here. So these are truss elements. So truss spacing, okay, is closer, meaning the joint to joint distance is shorter. That is what we mean by truss spacing closer. If we what? If we compare to true truss, okay, easier to widen in the future. So widening is easier. Okay. True truss. So true truss is where the truss portion is above the pavement. So in the previous slide, deck truss, meaning deck is always below the pavement. Okay? That's why it's very easy to memorize. Deck truss, meaning the truss portion is below the pavement. So true truss, that means the truss portion is above the pavement. Okay? So runs between trusses close to bottom chords. So true truss elements is wider than compared to deck truss. Desirable when vertical clearance is limited. Okay? Sidewalk can be inside or outside trusses. Okay? Just like in our own country, we have what? Quiapo Bridge. We have the what? Sidewalk that is outside the truss. Okay? Partial true truss. Partial meaning there are portion above and portion below. That's why it's called partial true. Similar constraint to true trusses. Truss type needs to have vertical members. Okay. All sway bracing stays below the bridge deck. Okay. The sway bracing are below the deck. Okay. So meaning this has something to do with our design. So remember these things because we will design, we will compute. Okay. That's why we need to understand these technical terms. Okay. Cable stayed bridge. Okay. The tied bridge also use cable steel, but this one is what we call cable stayed bridge because take note of the cable. They are diagonal and so on. They have different what angles. Okay. Tied bridge is where we are using what arcs. Then the what the cable is actually suspended directly vertical. Okay, vertical. Okay. So that is similar to the new what Binondo bridge. That is tied bridge. Binondo, new Binondo bridge. Okay. In Manila. Okay. Tall towers. We just need what? But for example here, there are only two high columns for cable purposes. Okay. Okay. There are only two expensive columns. And the other columns are not expensive anymore. So there are only two. 1, 2. Okay. So these are also pairs, but they are much economical than this two. Okay? Why? It is even economical to use this rather than to put up several piers into this into this area, because it is always expensive to put up columns or piers coming out of the bottom of the river or bottom of the sea. Okay, so it is harder, it is more expensive. Okay, it could be done, but it is more expensive. So we can do it, but make it less number. For example, we need, for example, 10 to 12 piers. Okay, just do 2 piers rather than 10. So we can economize, okay, the cost. So stay cables attached to edge girders. So the beams, which are called girders. So we attach the cables. Okay. So the next type is the suspension type of bridge. Suspension bridge. Okay. Suspension bridge. So there are also vertical cables, much like in arch bridge. The cables are vertical, but here the cable is suspended from another cable. So this is a cable, a big cable, and then smaller cables are suspended vertically from that main cable. Okay, that's why it's called suspension bridge. Okay, so there are only two towers that supports the suspension cable, and then the suspension cable have tie cables. Okay, so main cables outside the edges of deck. Okay, so the main cables are outside the edges of deck and drape over towers. So this is what we call drape. Drape. Okay, so the vertical hanging cables from top to the deck portion of the support. That is what we call drape. Drape over, no? Drape over towers in saddles. Okay. So what are the saddles? These are the saddles. Okay. These are the saddles wherein the drape cables are connected. So these are the saddles. Okay. Vertical cables support deck at relatively short interval. So there are so many. So there are so many cables. Okay. Very light superstructure. Okay. This is when we need to economize. Appropriate for spans of greater than 3,000 feet. 3,000 feet is about 900 meters. That's almost 1 kilometer. 900 meters, about 9 kilometers. Okay. Okay, so or more than that, this type of bridge is possible through girder bridges. So main support girders located outside the deck. So through meaning that is above the pavement, or in this case, this is not a pavement, this is railway. Okay, so rails, above the rails. So this is now railroad engineering and using bridge. So a small bridge, right? There is a small bridge in order for the rail to pass through. Disadvantage, soil, topography here. So the soil is not straight, so therefore a small bridge must be placed there. Okay, so main support, the girders located outside the deck, useful where vertical clearance is limited. Okay, and heavy loads are anticipated. So this load is heavier than the normal vehicular load because passenger trains not very much heavy, but the baggage trains, the luggage trains, those are heavy. Okay, common superstructure type of railroad bridges. So this is part of the superstructure. This is a girder. This is a girder. This is a girder beam. This is a girder beam. With what? You can see the bracing. Can you see the bracing? This is the edge, but 1, 2, 3, 4, 5, 6. There are 6 brace. Okay, bracing. Those are bracing. That is what we call bracing. This is a steel girder. What we mean is a steel beam with bracing. Okay? So instead of looking like W type of beam, there are portion wherein the the upper plans and the lower plans and the web is connected or welded with what? Welded with bracing. So additional support. Against what? Against buckling. This is for buckling. Okay, against buckling. Okay. And for what? Different types of buckling. So global buckling, local buckling. Okay. So mainly for local and global buckling. So deck through girder. So deck girder bridges. Common superstructure type for highway bridges. That is the common type. So as you can be familiar with our country's bridges, that is the most common superstructure type of highway bridge. So highway and railway engineering includes bridges. Okay. Girder beam bridges, versatile shape and configuration. So as you can see, this is a W type of beam. Okay, this is the W type of beam, but there are braces. There are bracing where the bracing is actually connected to the what? To the truss. Okay, trusses. Okay, trusses. Okay, so then on top of this, decking will be put up. Then on top of the decking, the pavement will be placed. Okay. So that is what we call girder beam bridges. So what is this? Girder, deck girder bridges. So deck girder type of bridges and girder or beam bridges. That is what we call girder bridge or beam bridges. What is this? Deck girder bridges again, but this time we have what? Floor beam bridge. So we have floor beam, okay? And substringer bridge, okay? This also called substringer. These are stringers. So these are stringer. This one, stringer, 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 stringer. So where is floor beam? The horizontal, this one. This one, the in your screen, horizontal part. Both, they are all horizontal, but in the picture, considering your point of view. So this is what? This is the floor beam. This is the floor beam. This is the floor beam. Right? That is a beam that is called floor beam. And connected to that, or it could be on top of that. It could be on top or connected to that on the same level. Is what we call stringers. Stringer, these are a smaller type of beam. They are also beam, but they are smaller and connected to floor beam. So floor beams are usually supported by girders. So girders, then floor beam, then stringers. then decking, then pavement. Okay? So there are several trusses components here. Okay? So trusses, these are actually small trusses. And okay? Okay? So look at the bracing. There are bracing for the what? For the floor beam. Okay? So what are the differences? Of floor beam, girder, stringers, they are all type of beams. Smaller one from the other. So we can differentiate them all together. So again, this is your professor, Dr. EYPEI, always preaching engineering information. Really.